Next, we'll take a look at security guards. Now, security guards are one of your best physical security components. They are also the most expensive security mechanism, but they provide a conditioned response. They interpret the situation and provide discriminating judgment. In other words, instead of a sprinkler system that floods a room if there's a high temperature or smoke detected, security guard might just grab a fire extinguisher and put out a small smoldering fire and of course provide substantially less water damage in this case. So we get the discriminating judgment as far as the response is concerned. There are many tasks that the guards can satisfy for us in regards to physical security. They can keep an eye on the employees as they leave and make sure the employees aren't stealing our property. They can enforce regulations. Now, this means they need to be trained in what our regulations are. They monitor the intrusion detection systems like the closed-circuit TVs, like the PETUS fences and the fire alarm systems. They can walk the perimeter and make sure that doors and windows are locked and that fences and gates are secure. They watch for suspicious activity. At our entranceways, they maintain the security on piggybacking. In other words, they approve one guy to enter and they only allow one guy to enter. No one guy swipes a card and three guys go into the facility. And we have them peruse or tour the facility to make sure that all areas are secure and remain secure throughout the night. So there are pluses and there are minuses regarding security guards. The pluses, they are able to make judgments and they provide a qualified response. They interpret a little more intelligently. And again, these are our best physical security components, but they are also our most expensive physical security components. So when it comes to monitoring, again, our best surveillance technology is a security guard. He is quick to respond, he is intelligent, and can provide this conditioned response. We also could use dogs for monitoring. Dogs provide early warning in that they'll sense early and start barking. They also are a good deterrent in that bad guys don't want to have to deal with a guard dog. In addition to these two, we can implement closed-circuit TVs. Now, closed-circuit TVs simply extend the vision of the security guard, because a closed-circuit TV without security guards monitoring and reacting are really of not much value. Here we see different levels of the quality of closed-circuit TVs. Of course, the higher the quality, the more information we're going to get, but also the more expensive these closed-circuit TV devices are going to be. So we can install rudimentary closed-circuit TVs for simple detection. They can identify that there's motion where there shouldn't be motion, the presence of an intruder. We can go to the next level where we might be able to identify what the intruder is doing. And finally, with the highest grade closed-circuit TV, we might even be able to get a worthy enough photo of the individual, of the intruder, so that we could identify them. So let's look at these issues regarding closed-circuit TVs. First, are we simply trying to identify someone is there? We're trying to identify what the intruder might be doing, or we're trying to actually identify the intruder. What is the purpose of the closed-circuit TV? What level of quality do we need with these camera devices? What environment is this camera going to work in? If it's internal, the devices are usually less expensive because I don't have to provide all the weather-related protections versus the external cameras where I have to secure them from temperature, from moisture, and even from vandalism. We want to consider the field of view that's required. How large an area is this closed-circuit TV going to cover? And this will have an impact on lighting and lensing on the closed-circuit TV, two issues we're going to be addressing momentarily. Next is the amount of light required for this closed-circuit TV. A lesser expensive CCTV will have a fixed aperture. In other words, it always requires the same amount of light. If this is an external device, that means during the day it'll use sunlight for illumination, but at night I need to provide that illumination through other means. And finally, we need to recognize that these closed-circuit TVs are simply one piece in this layer upon layer upon layer of security. I'll use the closed-circuit TV in conjunction with security guards, intrusion detection systems, and other alarm systems. So again, I need to identify what areas do I need to cover with closed-circuit TV monitoring. I need to identify the lensing type and the illumination required to provide proper video from the closed-circuit TV. Here we see the basic components involved in a closed-circuit TV system. We have the cameras themselves, which must be mounted properly with the proper lensing and apertures selected. We need to provide those cameras cabling and a feedback system where we can actually gain access to the information the camera is recording. Now that information is usually channeled through a control unit. This control unit actually coordinates the signals from the various cameras and then feeds that coordinated signal into a recording device, which places the images usually in a grid pattern so that I can on one image on a monitor view 4 or 8 or even 16 different areas of my facility, and then with the use of a control panel I select a single area and zoom in on that one individual area, but then roll back to the monitoring of all 16 areas if I choose to. Again, we generally want to record this information on a magnetic media such as a VCR. We talked about lensing. We have a fixed focal length or a variable focal length. This would require much more sophistication on the part of the closed-circuit TV lens. A fixed focal length is relatively inexpensive and simple, but again, it only gives you one area of focusing, one area where you can actually see what's going on. We also want to consider the depth of field. Now, this has a relationship to the aperture. The greater the aperture, the narrower the depth of field. The more tight the aperture, the smaller the aperture, the greater depth of field. So I want to identify what area, what region or range of depth is in focus. Then, of course, related to that aperture size has to do with the amount of light required in order to acquire an acceptable image. And then finally, I need to consider the secure mounting of the closed-circuit TV and of the power line and the feedback line so that a bad guy can't simply go cut the power cable and now my closed-circuit TV is rendered ineffective. So here we see several examples of the types of closed-circuit TVs that you might be interested in positioning around your facilities. We have external types and internal types, and then we have the multiplexing and recording gear as well as monitoring equipment.